Welcome. This is a probability tutorial. Okay, and what we'll be learning is the basics of probability, and then we'll go to advanced level. Okay, so basic formula of probability is, let's say P of A, okay, where A is an event, okay, equal to N of A, okay, where the event is divided by sample space. This is for the event. I'll give you an example for this. Let's say we toss a coin. There is a head and a tail, okay, two probability, there is a head and a tail. Now then sample space N of S will be 2, okay, and the probability of head we need to take out, so this will be 1. N of A, in this case N of H, it's 1, so probability of a head is 1/2. Similarly, if we take now two coins, okay, then there are probability head head, head tail, tail head, and tail tail. Okay, there are 4 types. Okay, and now what is the probability that we get a tail? Okay, one tail. What is the probability we get one tail? Okay, so it will be P of single tail, one tail. Okay, it's how many cases are there where one tail? 1 and 2. So 2 divided by how many sample space? Sample space means how many are there? There are 4. Okay, so 1/2. Okay, now we go to a little bit of formulas. Okay, and in this case there are, okay, what is mutually exclusive? Mutually exclusive means there is nothing in common. Think this is a Venn diagram. If there is something in common, then we give this is common. But for mutually exclusive, there is nothing in common. Okay, they are two different things. Okay, this is mutually exclusive. Okay, and for this, let's say we have a formula, okay, P of A union B, and we need to take out, this is probability of A, these are few formulas, probability of B minus probability of A intersection B. Okay, and I will explain this formula now. Okay, probability, see, this is the Venn diagram. Again I am drawing. Let's say we need A union B, means this has to be only once. Okay, but we take probability of A, means A we are taking, this is A, we are taking probability of B, so we are taking this entire thing. Okay, see, you will find that this is taken, this part is taken twice. Okay, this part is taken twice, once for this, once for this, so we need to minus this, subtract this part. Okay, so this part is A intersection B. Okay, now one more thing. Okay, okay, let's go to a sum. Okay, before we go further, let's see, there are 3 urns. Okay, because we need to cover another topic now. Before that, I need to give this example. Okay, let's say there are 3 urns. Okay, and first urn contains 3 red ball and say 5 black ball. Second urn contains say 6 red balls and say 2 black balls. Okay, and third urn contains say 4 red balls and 4 black balls. Okay, now we need to find what is the probability of getting a red ball. Okay, what is the probability of getting a red ball? Then how will we find? First we need to choose any of the urn, and then we need to take a ball out and check whether it's red or not. So we choose the first urn. Okay, so let's say probability of choosing a red ball is R equal to, okay, we choose the first urn. How many urns are there? 1, 2, 3 urns. Okay, out of this we choose the first urn, so 1 by 3. Okay, we are choosing first urn out of 3 urn. And remember, multiplication means and this plus means or. Okay, so let's now convert this into a language. Okay, so we are choosing the first urn, and then after choosing the first urn we will choose the red ball. So how many balls are there? Red, 3. Divide by how many total number of balls? 8. Okay, or this plus means or we will choose the second urn. Okay, second urn we are choosing how many ways? 1 by 3 ways. First out of 3 urns are there, we are choosing 1 urn, and then red ball 6 by 8, or we will choose this urn 1 by 3, and we will choose the red ball 4 by 8. Okay, so this is P of, let's say this is not actually P of R, this is actually, okay, this is P of R. Let's say we have taken this P of R. Okay, and now what we will be doing is, let's say what is the probability that we are choosing this first urn, and then we are choosing the ball and its red. Okay, so probability, let's say this is A1, this is A2, this is A3. So probability of choosing the first urn and then finding the ball is red. How will you write? Probability that you are choosing the first urn. Okay, A1 is for choosing this, probability of choosing first urn, and okay, we are giving this, and after this event has occurred. Okay, this means after the first event has occurred, we have already chosen the first urn, and then we will select the probability of getting the red ball. Okay, so after A1 has occurred, we are choosing red. So what is the probability? This will be this first, so this, okay, this is the probability of choosing the first urn. Okay, into, let's say this, we are choosing first urn out of the 3 urns, and then we are choosing the red ball, so 3 by 8, divide by this entire thing. Okay, so P of R. Okay, so this is probability, and we can write this as formula also. We can write, if we write this as a formula, probability of choosing the first urn and probability of choosing red ball. Okay, red ball after first urn has already occurred. Okay, this is the way that you can, if you want the formula, then this part is the formula, and if you want, okay, so this is for when we are, this is actually Bayes' theorem. Okay, if you want the definition, this is Bayes' theorem. Okay, we are choosing the one event, and after one event has already occurred, then we are choosing another event. Okay, what is the probability that a leap year has 53 Wednesdays? Okay, what is the probability that a leap year has 53 Wednesdays? So how many days a leap year has? 366. Okay, so if you divide it by 7, 366. Okay, you will get 52. Okay, and the remainder, if you see 7 5 ja 35, 1 6 7 2 ja 14, 2, so remainder 2. So that means we have 52 weeks and 2 days. In these 2 days it will be whether Sunday, we have 2 days, so in these 2 days we will have either Sunday Monday, or Monday Tuesday, or Tuesday Wednesday, or Wednesday Thursday, or Thursday Friday, or Friday Saturday, or Saturday Sunday. Okay, so our probability of Wednesday is, how many cases Wednesday is there? 2. So 2 divided by how many total number of cases? 7. So this is the answer. Okay, so a leap year, this is the question, that if a leap year has 53 Wednesdays, then the probability 53, what is the probability that it has 53 Wednesdays? Okay, means the last 2 days either one will have a Wednesday. So this is the answer. Thank you. Before going further, we'll take a sum. Okay, now let's say they have given us P of A equal to half P of B, let's say they have given 1 by 3, and P of A intersection B they have given 1 upon 6. Okay, they have asked us calculate P of A union B. Okay, so P of A union B equal to P of A plus P of B minus P of A intersection B. We'll just put the values, half plus 1 upon 3 minus 1 upon 6, and you will get the answer. Okay, we'll discuss some topics now. They might ask, is A and B mutually exclusive? Okay, so let's check. Is P of A intersection B is 0? Our answer is P of A intersection B, they have given 1 upon 6. So answer is no, because there is nothing in common. If there is anything in common, okay, then this will not be 0. Okay, mutually exclusive means this has to be 0. Okay, but it has a value, so it's not mutually exclusive. Okay, second part is A and B exhaustive events? Exhaustive. When it will be exhaustive? If P of A union B equal to 1. If, okay, if A union B is 1, means there is nothing else remaining. Think this is the Venn diagram. This entire thing constitutes 1. 1 is the complete value. That means outside there is no value, there are no values left over here. All is contained within, means it has exhausted the entire sample space. Then we say it's exhaustive. But our A union B, if we calculate, let's see, if we calculate this, LCM is 6, so 3 plus 2 minus 1. Okay, 3 plus 2 minus 1, we get 4 upon 6. So it's not 1. Okay, so answer is no, it's not exhaustive event. Number 3, is A and B equally likely, we need to check if P of A is equal to P of B, then it's equally likely. We have now half and this is 1/3, so they are not equal, so no. Okay, now our fourth part is A and B independent events. So if we check, how we'll check? Okay, for independent, in your A intersection B is equal to P of A into P of B. Okay, now our P of A intersection B is 1/6, and if you see here, this is 1/2 and 1/3, so they are equal. So yes, they are independent events. Okay, now so what we have covered: mutually exclusive, equally likely, independent events. Okay, and now we will come to another part, which is for De Morgan's theorem. Okay, in probability. So let's say they are asking, they have given for the same question, let's say they have given find P of A complement intersection B complement. Now you will be wondering, A intersection. Okay, so you will be wondering how will we find this, right? So according to De Morgan's, P of this will be A union B whole complement. Okay, and now this is equal to this. Okay, so we can write 1 minus P of A union B, so equal to 1 minus P of A plus P of B minus P of A, let's write here, minus P of A intersection B. Okay, so what are the values? We have the value of P of A, so we can just substitute half plus 1/3 minus 1/6, and you will get our answer. Okay, so basically De Morgan's theorem is, if there is complement intersection this, then it will be like this, and vice versa. Okay, now let's go for dice problem. Okay, let's say for single dice, if there is one dice, then there are 1 to 6. Okay, either it will be 1, either it will be 2, like that. So what is the probability of getting 3? It will be, there is only 1 3, so 1/6. Now the main part comes is 2 dices are thrown simultaneously. Okay, what will, how now this, if not done in proper way, it will take a lot of time. So we'll just draw this way: 0 1 2 3 4 5 and 6, and 0 1 sorry, no 0. Okay, from 1, because there is no 0 in dice. 1 2 3 4 5 and 6. Okay, you can say this one is 1 1 1 2 1 3 1 4 1 5 and 1 6. Okay, similarly 2 1, you need to complete this: 2 2 2 3 2 4 dot dot. We will just give dot dot. Okay, you can complete this thing. You need to complete this in order to get that. Now, what is the probability of getting a doublet? Probability of getting a doublet. What is a doublet? If you have 1 1 1 2 2 2 3 3 4 4 5 5 and 6 6, it's a doublet. So there are 6 values for a doublet, and total sample space is 6 multiplied by 6. 36 is the total sample space. Okay, so sample space is 36. So probability of getting a doublet is 6 upon 36 equal to 1 upon 6. Now they might ask what is the probability of getting sum 3? Probability of getting sum equal to 3. Sum equal to 3 means you need to calculate, like 1 and 2 gives 3, 2 and 1 gives 3, 1 and 2 gives 3, 2 and 1 gives 3. So hopefully there are no more. So 1 and 2 and 2 and 1 gives 3, right? So you have two values for this event, and total sample space is again 36, so it will be 2 upon 36. Okay, now let's go. Okay, now we go for cards. In cards there are 52 total cards, and we have 13 of diamonds, 13 of hearts, and this is spade. Okay, we can draw hopefully this one. Okay, and one more is there, like this. Okay, so this is club, 13 club, this is diamond, heart, club, and spade, 13. Okay, and if you multiply 13 multiplied by 4 is 52. Okay, in each deck, okay, in each group, say let's say diamond, there is one ace, then 2 3 4 5 dot dot is there, and you can say there is one king, one queen, one jack, and this goes up to 6 7 8 9 10. Okay, so in total, okay, this goes up to 1 to 10, and this. Okay, so this is the basic cards. Okay, and now we'll go for sum. Let's say they are asking, draw a card from a deck and draw a card. Okay, so we are done with the details of the cards. Okay, how many cards are there, what are the cards. Okay, and now we'll go for sum. Let's say they will ask that what is the probability that it's an ace, probability of an ace. Okay, so how many aces are there? Okay, there are 4 aces. Out of that we are drawing only one ace, one card. Okay, so and the sample space is 52 C1. Now they are actually asking what is the probability that you draw one card and it's an ace. So we are drawing one card from, okay, the pack, and sample spaces there are in total 52 cards, from where we are drawing one card, and probability of ace, there are 4 aces, each group has one ace. Okay, so 4 out of 4 aces we can get 1. Okay, so 4 upon 52. Okay, they might similarly ask what is the probability of getting a king, a queen, like that. Okay, now we'll go to a little bit complicated one. Okay, think what is the probability that we are drawing a card and it's an ace or let's say 5. Okay, so before going further we need to first get this thing, or and AND. Okay, union means or, intersection means and. This is language of probability. If there is a plus, it means or. If it's multiplication, it's and. Okay, so you need to remember this. So they are actually asking us ace or 5. Okay, if such a condition happens, it is just an example I have given. Okay, so we are not doing this. We will be doing, let's say they are giving us to find it's a 5 or a club. Okay, it is a 5 or a club. Then we need to find the probability of a 5 and club. Okay, so P of 5 union club. Okay, equal to, we will write P of 5 plus P of club minus P of 5 and club. Okay, now we will be writing P of 5 in so probability of getting a 5. Okay, so probability of getting a 5 in the club, okay, is, let's say probability of getting a 5 in the deck, entire deck, not club, entire deck is, let's say there are 4 5s in the entire deck, so 4 by 52 plus club. Okay, there are 13 clubs. Okay, 13, actually it's 4C1, we are directly writing 4. Okay, because 4C1 is 4. 13C1, we are drawing only one card, so 13 upon 52. Now there is a condition when it's a 5 also and a club also. So how many 5 are there in a club? There are 13 cards, so there are 1 5 and it's a club out of 52. You will calculate, you will get this answer. Okay.